So I think this is video 5 on kind of Taylor series, review, crash course, whatever you want to call it. College Board likes to ask questions like these. This would be, I think, a calculator question because of part C. We'll get there in a moment. All right, so they say f is the function, f of x equals e to the negative 2x squared. So the first thing they want us to do is find the first 4 non-zero terms in the general term for the expansion of that thing, about x equals 0. Based on what you probably just watched, you should say, oh, about x equals 0. That means it's a Maclaurin series. It's just a Taylor series that's centered about x equals 0. And then the next thing, you find the interval of convergence. How are we going to do that? We're going to use ratio test. And then part C, we'll talk about that when we get there. What I want to say before we do this is that there are some series, I don't like memorizing, but there are some series that are good to memorize before the AP test. And I'm going to scroll up a little bit, and I have them right here. So the series for e to the x is 1 plus x squared, and I divide that by 2 factorial, plus x cubed divided by 3 factorial, plus x to the 4th over 4 factorial, plus dot, 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 out to x to the n over n factorial. And the more terms we add, the more it, quote, converges on e to the x. And you should have seen some of that somewhere. So e to the x is easy to remember because it's just x to the thing divided by that thing factorial, and they're all positive. So sine is just all the odds, 1, 3, 5, 7, and they alternate positive, negative, positive, negative. If you're in my class, at some point we did something with this where we kind of guessed our way into it, and you should remember that. And then cosine. Oh, and then the other thing I'll say, we know that sine is an odd function. That's a term from like algebra 2 and pre-calc. Oh, snap. It's got all the odd exponents in it. All right, so the series for cosine. And then this over here, like, I don't know, that might be hard to memorize, but you should at least have these down. And then the series for cosine is all the even components, because cosine is an even function. This one is the same as x to the 0 over 0 factorial. And yes, 0 factorial is 1. Type it into a calculator, you'll see. But all the even components, again, alternating signs, plus, minus, etc. And this would be the general form for cosine. Hey, wait a moment. Cosine is the derivative of sine, isn't it? What happens if you take the derivative of x? What is it? It's 1. What happens if you take the derivative of this messy term? I'll do it over here. I would have 3x squared over 3 factorial. Well, the 3 factorial is 3x squared over 3 times 2 times 1. Those cancel. Give me x squared over 2 times 1, which is x squared over 2 factorial. Oh, snap. This has a minus. This term derives to that term. What do you think this term does? Ba-boom. What do you think this term does? Ba-boom. What do you think this term does? Oh. Okay. And then, just really quickly, if you were to take this and then make it negative, or take this thing's derivative and make it negative, I think you'd probably come up with all these terms. Can you see that? Take the derivative of this, make it negative. Whoa! All right, anyway, let's go and do this problem. It's me trying to convince you that, okay, these things maybe are true and connected. All right, so here, so look, we're back up. Oh, man. All right, so we're going to use this one right here, e to the x equals. So I'll write it out for you down here. And we're going to stick with purple. So e to the x is 1. It says the first 4 non-zero terms. So I'm going to go 1 plus x squared over 2 factorial plus x cubed over 3 factorial. I can stop there because I have 4 terms, right? 1 and this and this and this. I don't have to go to x to the 4th. Sometimes you want to be careful about what they say and how we read. And they also ask for the general term, so we're going to go ahead and include that as well. So plus, I'll write dot, 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 plus x to the n over n factorial. Now, look, so why did I do e to the x? Because I have e to the negative 2x squared. So if I wanted to do e to the 4th, or get an approximation for e to the 4th, I would do 1 plus 4 squared over 2 factorial plus 4 cubed over 3 factorial. I can change the x value on the left side, and then I just change whatever it is here to whatever I want it to be. Notice this has e to the negative 2x squared. So what I'm going to do is write e to the negative 2x squared equals the 1 stays the same, and then that thing is going to go to this right here was that. It now just gets changed to this. So I get minus 2x squared plus boink boink squared over 2 factorial. What goes in there? Well, the x got replaced with this. So I replace this x with that. So I get negative 2x squared. And then I get plus, boink boink cubed over 3 factorial. And I'm going to write negative 2x squared plus dot 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 plus boink boink to the n over n factorial. And I'm going to write negative 2x squared. So that's an answer. We can simplify this. It might be multiple choice. We're going to simplify this. This is 1 minus 2x squared plus, all right, so look, when I square this term, the negative gets squared out because it's an even exponent. The 2 goes to a 4, and then the x squared gets squared. That becomes x to the 4th over 2 factorial. Plus, actually, no, this one is going to be minus. Why is it minus? Because the negative is going to get cubed, and I'll have 1 left over after 2 of them cancel. And I'm going to have an 8, because that is 2 cubed. X to the, remember your exponent rules correctly here. This is a 6th power, not a 5th power, over 3 factorial plus dot dot dot. This thing stays the same. All right. So we could kind of simplify some of these factorials if we wanted to. I'm going to just move on to part B because I'm going to run out of time otherwise. You could also rewrite this in a little bit different way as well. Oh, this should have an N up there. There we go. All right, so when we want to find the interval, notice this is a summation. This plus this plus this plus this. We are doing, this is the inside of the summation that we're doing. This is the sum from n equals blank to infinity of negative 2x squared to the n over n factorial. And I'm going to put n equals 0 here. Why does it start at n equals 0? Because that gives us this term right here to be 1. Hopefully you're okay with that. All right, and then look, so part B, they ask us for the interval of convergence. How do we find the interval of convergence? Well, we use the ratio test. What are we going to do the ratio test on? This right here. So that's why I wrote that out. So part B is L equals limit as n goes to infinity. And it's the same thing we've been doing. A sub n plus 1 over a sub n. It's the same thing that you should be good at by now. You should be really good at the ratio test. Equals. All right. So limit as n goes to infinity, absolute value. There's a variety of things we can do here. I'm going to write it out. Negative 2x squared over n factorial. Oh, sorry. Oop, not squared. To the n plus 1 over n plus 1 factorial times, copy dot flip, n factorial over, what do I have? Negative 2x squared to the n. All right, so there's a variety of ways that we can think about this. I guess I'll go and rewrite it the way we like to. Limit as n goes to infinity, absolute value, negative 2x squared to the n, there's a negative there, over negative n plus 1, 2x squared to the n, times n factorial over n plus 1 factorial. All right, so what cancels here? Well, there are n of these down here. When I cancel them, there is 1 remaining. That to me is the easiest way to see this. And then this cancels with everything but the previous, or everything but the last one. We've talked about that so far in this video series. Go backwards if that is confusing. So what do I get? This is the limit as n goes to infinity of the absolute value of negative 2x squared over n plus 1. So the negative, you could say it cancels out because of the absolute values, but we don't even really need to go there. So what I want you to see is that negative 2x squared, but I'm letting the bottom go to infinity. Okay? Doesn't matter how big this is up top. The bottom's going to infinity. What happens? This thing just goes to 0. It goes to 0 because the bottom grows faster than the top. And that's the way these limits work. And look, that's less than 1. And we had one like this earlier. What happens when, no matter the x value, the ratio test always gives us 0? Well, this thing converges for all x values, just like that previous one that we had a couple videos back did. You could write it like that. You could write converges for that. Oops, I don't know why that erased. That means all real numbers. Or you could write negative infinity less than x less than infinity. All right, hopefully we're good there. I'm going to speed this up to get to part C in. So part C says, given let the function be the first 4 non-zero terms, show that, look, this is f minus g. G is this new function. F is the original. So what that is the error between f and between f, the function, and g, the approximation. So we want to show that the error is less than 0.02 for this x value, x between negative 0.6 and 6. So what we're going to do is use alternating series error bounds. Notice it said the first 4 non-zero terms. What do we do for alternating series error bound? We go to the next term. So what we need to do is find a sub 5, which is negative 2x squared to the n over n factorial for n equals 5. If I plug that in, what we wind up, or sorry, for n equals 4, because the fourth term here had a cubed up there. So it's actually this n to the 4th. Anyway, what you get if you plug in n equals 4 there is we get 2/3 x to the 8th. That is just making n equal 4 and then simplifying. And then what we do is we can plug in the x value that they gave us. The x value that they gave us was that 0.6. So if I do that, a sub 5 of 0.6 equals 2/3 times, type it into a calculator, 0.6 to the 8, which is 0.011. That is less than 0.2, which is what I wanted to show it was right here. So, and then by alternating series error bound, the error is going to be less than this right here, which is less than 0.2. So I would write by alternating series error bound, it's less than blah, blah, blah. Thanks. I'll see you in the next video.